Hi! In today's video, we shall go through how to use R for a multiple linear regression model with only quantitative variables. Simply put, linear regression is used to create a best estimated linear relationship between a quantitative variable against either another quantitative or categorical dataset. Simple linear regression deals with only two variables, while multiple linear regression deals with multiple variables which could be solely from quantitative data or a mix of quantitative and categorical datasets. We shall first go through the linear regression and multiple quantitative regressors in this video. We shall assume that the data has been imported by our own methods, and now we can move on to the more technical part of the code. Like a simple linear regression, we must first check that the data is suitable for a linear model by plotting a scatter plot for each of the independent variables used, and seeing that they are not skewed or distributed in a non-linear way. Since we have done this in a previous video, which is similar to the simple linear regression one, we can omit this in this video and move on to the more technical parts. But we can always check again after getting the summary of the linear model generated, as explained in the previous video on simple linear regression. Now, we just need to use the linear model function, which is lm bracket the dependent variable tilde the independent variables. In this case, because we have three independent variables, we just need to write a plus sign between them. So from the code, you can see that is the price of house tilde age plus distance from the MRT plus number of convenience stores nearby. Then we use the summary function to view the estimated coefficients of the linear model, and it also provides us with other information that I'll be going through. After using the summary function, we see that the y-intercept is 43.0 and the different coefficients for the regressors for age, distance, and stores is negative 0.253, negative 0.005, and 1.30 respectively. This determines that the best estimated linear model between the datasets is that the prices of the houses equals to 43.0 minus 0.253 times the age of the house minus 0.005 times the distance from the MRT plus 1.230 times the number of convenience stores nearby. The p-value for the various coefficients are all less than 0.01, which suggests that there is strong evidence that the regressors are significant for a linear model. But while each regressor have a small p-value, we still need to use the overall p-value from the f-test, which can be found at the bottom, to determine that the overall linear model accounting for every regressor in the linear model is still significant, and thus indicate that there is a possible linear relationship between the dataset. Now, to interpret the meaning of the coefficient, it just means that after fixing the other regressors, like for example, we fix the distance and the stores, then the price of the house in that region is affected by the age by a reduction of 0.253 in the price of the house for each year that the house gets older. And if we fix the age and the stores, there is a 0.005 reduction in the price of the house for every meter it is away from the house from the MRT. And then if we now fix the age and the distance, for that same age and distance, the price of the house increases by 1.30 for each additional unit of convenience store there is nearby. Like the simple regression model, we want to use the predict function to interpolate a value of the price. So we just need to input a data frame with three inputs: the age, the distance, and the store, and it uses the predict function to predict the price of the house. Now, I've come to the end of the video on how to use R to get a multiple regression model for quantitative variables only, and I've hoped you have enjoyed it. Feel free to like, share, and subscribe, and comment on any other points that I've missed out and can address in the comment sections down below. Thank you.